Hello, welcome everyone. Welcome back to my channel. Today we are doing frustums. We have already completed frustum of cones and today we are starting frustum of pyramids. Well, pyramid we have already done. What is pyramid? What are the types of pyramids? So it would be much easier for you now to understand the frustum of pyramids. Since we have already done the frustum, so you might be aware what are frustums. It's just if you cut off the upper part, then you will get the required shape. That's your frustum. So whether it's a cone or pyramid, if you cut down its upper part, then the remaining shape is called as frustum. Here you can see this one, this diagram. Here you can see this is a cone. Well, the top part has been chopped off, but it's actually a pyramid, or you can say this one. This one is a pyramid. When you cut off the upper part, that means this along the surface, along any surface which is parallel to the base. It has to be parallel, right? This base and this base, they should be parallel. Then when you chop off this part, the remaining will look like this, and this is called frustum of pyramid. Now, because we know there are different types of pyramids, because pyramids are defined by their base. So if the base, that means this one is a rectangle, this is called rectangle base pyramid. If it's a square, it's called square base pyramid. If it's a hexagon like this one, so this is called hexagonal pyramid. And if you chop off its upper part, then it's called a frustum of pyramid. And which pyramid? Hexagonal pyramid. So as there are different types of pyramids, so does the different types of frustum of pyramids. Now, if we are studying the pyramids, the first and the most important thing is understanding their shape, how they are formed. And second thing which is important in your syllabus is finding the surface area and volume. If you're finding surface area and volume, there's one thing which is very important to understand, which is this one, that if I'm talking about the smaller, because when you are chopping off the upper part is also a pyramid and the bigger one is also a pyramid. That means this hole you can clearly see is a pyramid. If you cut down its upper part, that is your small pyramid. Still that will be pyramid. So that small pyramid, this small pyramid that you will cut off, and the bigger pyramid which was originally there, they both are similar figures. That means their shape is exactly the same, their angles is exactly the same, only the difference is in their size, and every corresponding side is proportional. So there is a length scale factor. By this, you can easily calculate any missing dimension. Say, for example, the length of the base is not given. So in that case, you can easily calculate that if the length of the base of the smaller one is not given, but the bigger one is given, and you manage to get the scale factor, it's very easy to find the missing lengths. So first thing that you have to keep in mind, that we did when we were doing frustum of cones as well, that the smaller cone that you will take it out, and in this case the smaller pyramid that you will cut off, is always similar with the bigger pyramid from which you have made the frustum. So that means if I divide the corresponding side, I'll get my scale factor. Moving back to this figure, if height of this bigger one is h1 and height of this smaller one is h2, then the ratio of h1 over h2 will give you the scale factor. If suppose scale factor comes out to be 2, that means every corresponding length is twice the other. So if I know the length of this one, say for example it's 10 centimeters, so I can easily understand that this will be 5 centimeter if the scale factor is 2. So this will help us in finding the missing dimensions. Now moving back to the surface area, coming back to the surface area volume that I was explaining, that And even for surface area and volume, it's very important to understand the scale factor. That's why we did it first. Now, surface area is basically the area of all the surfaces. If you look into this one, the square base pyramid, it has 5 surfaces, right? The bottom one and the 4 triangles. If you see the frustum will have one more surface, that is the upper part. This one. It has this upper surface, the bottom surface, and 4. Previously in pyramid, there were 4 triangles, but now there are 4 trapeziums. So if you want to calculate the total surface area, you have to calculate the area of upper and bottom. If it's a square base, so upper square plus lower square, and area of all the 4 trapeziums. Now let me see this question. Find the total surface area of the following frustum. This frustum has the upper part and the lower part 30-20. That means clearly it's understandable that it's a square base frustum, and the bottom one is a square of 30 times 30 area, and upper one is also a square. Now the other sides are basically trapezium. So let me see how can we calculate this one. So here we get to know area of upper surface, which is 20 times 20, 400 centimeters squared. Area of lower surface, which is also a square, and that is 30 times 30, that is 900 centimeters squared. Now area of the trapezium, each of these trapezium. So for trapezium, we know the formula says half times sum of the parallel sides. Sum of the parallel side is, this is 20 and this is 30. So 20 plus 30 and times height between them. So, and height between them is as given as 40. So I can say area of one trapezium is equals to half times sum of the bases, which is 20 plus 30, times height between them, which is 40. So that will be 50 times 20, that is 1000. Now total surface area would be, because 1000 is the area of one trapezium and there are 4 trapeziums, so 4 times 1000 plus 400 plus 900. So this will give you 5300 centimeters squared, and that's your final total surface area of this frustum. Now this one is a little different from the previous one. Previously, don't get confused, they have given this height, this length. Actually, you can see the distance between 2 parallel sides, that was given, but here it's not given. That is the height which is given, this height, the vertical height from the center of the base to the center of the upper surface. When you are moving, that dimension is given. In case of the pyramid, it's given as 50, and in case of this one where you have chopped it off the upper part, the smaller pyramid has the height 10. From here I can easily calculate the length scale factor. Here it's very important. So first thing I'll do is finding scale factor. So let me find length scale factor. So H1 over H2, that is 50 over 10, and 5 is the scale factor. You have the scale factor as 5, that means every dimension of the bigger one is 5 times of the smaller one. That means if this is 10, you can easily calculate this one be 2. So we can find length of the upper face which is 10 over 5, that is 2 centimeters. Now, to calculate the area of the frustum, this is our main aim. Area of the frustum is okay. Now I have the dimension of the upper square, dimension of the lower square I do have. Now I should know the distance between these two so that I can calculate the area of each trapezium. And for that, I already have this one. This pyramid will help me. How? Because this is from the center of the square. So if I move and draw perpendicular, it will reach to the center of this length. This length is 10 centimeters. So at this center, this is going to be 5 and this is going to be 5. And then I need to join this like this. This triangle. See, this triangle will give me this hypotenuse, this length. This length. This is actually the height of each triangle, basically. So I just need to apply Pythagoras theorem because this whole length is also 10 centimeters. So this part is half of it, simple. So I can say that this part is going to be 5 centimeters. So I have to apply Pythagoras theorem and it will help me in calculation of the height of the triangle. So height of each triangle of original pyramid is calculated by Pythagoras theorem. That means height, square of our height, which is 50, and square of our base, which is 5. So this will give me, let's say it's L. L squared is 50 squared plus 5 squared, which is 2500 plus 25. That is 2525. And finally, you will get root of 2525. From here, I can say that this would be 50.25. So the length of this bigger one, this one, for this triangle is 50.25. So length of this is smaller one, this one, for this triangle, is going to be 1/5 of it, which is 10.05. So then I can say length of triangles, or you can say height of the triangles would be much easier. So height of the triangles of smaller pyramid will be 50.25 over 5 because of the length factor. That will give you 10.05. So from here, the height of trapeziums, I'm talking about the trapezium surface. So trapezium surface would be, you just have to subtract them together. So 50.25 minus 10.05 will give you 40.2. That's the final answer. So I get to know that this length of the trapezium is nothing but 40.2. How I get to know that it is this? Because I have calculated this whole as 50. Because if this is 50.25, obviously height of each triangle here would be 50.25. So height of this is 50.25. For smaller one, I have divided by 5 and got the height, which is 10.25. So for this one, the height of the triangle of the bigger one, subtract height of the triangles of a smaller one, will give you the height of each trapezium. So from here, I can say, just a minute, I can calculate area of trapezium, of each trapezium. So it would be half times sum of parallel sides. So 10 plus 2 times height, which is 40.2. So from here, I can say my final answer for each trapezium basically is 241.2. And when you multiply it with 4, it will give you the area of each all 4 trapeziums, which is 964.8 centimeters squared. So total surface area would be now. So total surface area, sum of all the surfaces, bottom is 10 times 10, upper one is 2 times 2 plus 964.8. So it's 100 plus 4 plus 964.8. And thus you'll get the answer as final answer is 1068.8 centimeter squared. We have to calculate the volume of this frustum. So we know that volume is the total space covered by any particular object. If I'm talking about finding the volume of a frustum, I have to calculate volume of this bigger pyramid, and subtract the volume of the smaller pyramid. And obviously the remaining one would be the volume of the frustum. Don't find the total surface area of the bigger one, then subtract the total surface area of the smaller one, and you'll get the total surface area of the frustum. That doesn't work there. But here it's easy to understand. So first thing is I have to calculate the length scale factor. So I'll start with finding length scale factor, which is here 45 over 15. 45 is the height of the bigger pyramid and 15 is the height of the smaller pyramid, which is 3. So this will help me in finding once you have the length scale factor, you need not to find the volume separately. It's very easy. I can calculate volume of the bigger pyramid, which is, so volume of bigger pyramid is 1/3 times area of the base, and base is what? 12 times 12. If this is 12 times 12, this is also 12 times 12. So it would be 1/3 area of the base 12 times 12 height multiplied by 45. This will give you the volume of the bigger pyramid. So this one will give you 2160 centimeter cubed. This is the volume of the bigger pyramid. When we were doing the similar figures, I explained you one thing, that whatever be the length scale factor, if you're able to find the length scale factor, it's easy to find the volume scale factor. You just need to cube it. So if length scale factor is 3, volume scale factor would be 3 cubed, which is 27. So volume of smaller pyramid would be 2160 over 27. So 2160 over 27, which is 80 centimeter cubed. So finally, the volume of the frustum is the subtraction of both. So volume of frustum is, just subtract these two. So let me just write it a little properly. Of frustum is 2160 minus 80. So from here we'll get the answer as 2080 centimeter cubed, and this is the volume of the frustum. And this is how you can calculate the volume. Well, volume for any frustum is, you just calculate the volume of the bigger one, subtract the smaller one that's been chopped off, and you'll get the volume of the frustum. But that doesn't apply for the total surface area. Maybe for curved surface area you can just apply this method, definitely you can, but not for total surface area. So that's it for today for a volume of the frustum of pyramids. If you are looking for GCSE classes, live online GCSE classes where I'll be teaching, you can ask me the questions. It's just £6 per hour, and you just need to drop us an email at exacademy@gmail.com. We provide classes for every subject. and these are pretty affordable, and these classes are literally very helpful in improving the grades. I can share you all past results. I'm really happy to do so. And if you're looking for classes from year 1 to year 13 for any subject, I have tutors for all of them, and we have an experience of more than 5 years, and some has more than that, so definitely it's very helpful. If you're looking for free worksheets, it's there on our website, which is akziacademy.com. Or if you're looking for mock papers, because exams are pretty near, and it's just £10, you will get a whole complete set of papers and with the complete solution. And even those mock papers are pretty helpful. Definitely, if you solve them, it's definitely gonna help you. So yeah, that's it for today, and in the next class we will be meeting we will be back with the sheet, our worksheet on first term of pyramids. So that's it for today. Thank you. Have a great day.